Yellowstone caldera's magma reservoir contains substantial melt at depths that fueled prior eruptions.
Deep beneath the picturesque Yellowstone National Park lies a powerful force, a ticking time bomb that could unleash devastation with a force never before seen. This sleeping giant has remained dormant for over 600,000 years, but recent discoveries have shown that it may not remain so for much longer. Scientists have uncovered a sizable chunk of magma pulsating beneath the surface, sparking fears of another catastrophic eruption. What could this mean for the park and surrounding areas? Is there any way to predict when or if this monster will wake up from its slumber, and what will happen if it does? As officials at Yellowstone National Park continue to monitor this pulsating magma, questions arise about what could trigger an eruption and how much time we have to prepare. The last eruption left a massive crater, destroyed everything in its path, and caused worldwide climate change. Could another eruption be even worse? Should the park be evacuated? And what would happen to the millions of tourists who flock to the area each year? Come with us as we delve into the discovery made by Yellowstone National Park officials about a significant portion of magma that has begun to pulsate. Deep beneath Yellowstone National Park lies a fierce and powerful force, with around 10,000 geothermal features that shape the area's stunning landscapes. These features are driven by titanic forces of heat and pressure, causing the Earth's surface to rise and fall, much like a sleeping giant's breath. The park is situated across the states of Wyoming, Idaho, and Montana, with the bulk of Yellowstone and its volcano located in northwest Wyoming. Magma, a hot region of molten and semi-molten rock, lies beneath the supervolcano, causing the ground to swell and collapse as it flows into a magma chamber reservoir located 6 to 10 kilometers beneath the park's surface. Volcanologists have been monitoring this activity since 1923 and have observed a period of gradual continuous growth. From 2004 to 2009, the ground rose by around 25 centimeters, but in 2010, the ground started to sink. These changes have raised concerns about the possibility of an impending Yellowstone eruption and its potential intensity. The area is also rich in geological history, with rocks that date back to the Precambrian period over 541 million years ago. The region was formed through massive mountain building, volcanism, faulting, and glaciation during the Cenozoic era, which spans the last 66 million years of Earth's history. The Absaroka Range, created around 50 million years ago due to several volcanic eruptions, borders the north and east edges of the park. The western United States was once covered by oceans, sand dunes, tidal flats, and vast plains throughout the Precambrian, Paleozoic, and Mesozoic eras. The Rocky Mountains were formed by mountain building processes towards the end of the Mesozoic and beginning of the Cenozoic. With its rich geological history and powerful volcanic activity, Yellowstone National Park is a place of awe-inspiring beauty and wonder, but also a potential threat to those who call it home. The story of the Yellowstone volcano began millions of years ago when the west began to stretch along an east-west axis. This continual stretching process produced the contemporary basin and range topography along north-south valleys and north-south mountain ranges, including the Yellowstone region. Around 16.5 million years ago, an active phase of volcanism began close to the borders of modern-day Nevada, Oregon, and Idaho. As the North American plate moved over a shallow body of magma in a southwesterly direction, a trail of volcanic activity was left in its wake, forming a 500-mile path of more than 100 calderas. Yellowstone was transported nearer to the shallow magma body by the shifting of the North American plate about 2.1 million years ago. This is still what drives Yellowstone today. In the broader Yellowstone region, magma is present near the surface. The cause of this small mass of magma is the mantle's thermal convection, which melts rocks in the crust as magma plumes rise through the mantle, forming reservoirs of partially molten, partially solid rock. As tectonic plates move over hot regions, a trail of volcanic activity is left in their wake. The current Yellowstone volcano is unrelated to the period of volcanism that formed the region. Instead, the volcanic hot point that lies beneath the broader Yellowstone area left a swathe of volcanic deposits across Idaho's Snake River Plain as the North American plate migrated west during the past 16.5 million years. Two magma chambers of partially molten, partially solid rock are close to Yellowstone's surface, causing a portion of the crust above the shallowest magma chamber to expand and rise due to the heat. It's fascinating to think about the geological forces at work that have shaped Yellowstone and the surrounding region over millions of years and continue to do so today. As a result of pressure on the crustal layer, newly formed faults caused an increase in earthquake activity. These faults eventually reached the magma chamber, allowing magma to seep through the fissures. The eruption occurred when the magma relieved the pressure, causing volcanic gases to escape and violently explode. This led to the release of large amounts of ash and gas into the atmosphere, causing pyroclastic flows over the surrounding terrain. The land above the magma chamber sank and created Yellowstone's first caldera. This eruption was one of the most significant volcanic eruptions ever recorded, covering 5,790 square miles of land, reaching as far as Missouri 2.1 million years ago. The amount of volcanic debris spewed was estimated to be 8,000 times greater than the 1980 eruption of Mount St. Helens. A second sizable volcanic eruption took place within the first caldera's western margin around 1.3 million years ago. The current Yellowstone caldera was formed by the third and most recent major volcanic eruption 640,000 years ago, which was followed by 80 minor eruptions. One of these minor eruptions created what is now known as the west thumb of Yellowstone Lake about 174,000 years ago. The caldera floor and surrounding terrain were partially filled by enormous lava flows of viscous rhyolitic lava during and after these explosive eruptions, along with less substantial basalt lava flows. The youngest of these lava flows is the pitchstone rhyolite flow, which is located in the southwest of Yellowstone National Park and is 70,000 years old. Imagine a time when the majority of the continental United States was covered in a thick blanket of ash, gas, magma, and other volcanic debris. In fact, some of these materials have even been discovered as far away as Louisiana. This was all due to the prior eruptions of the Yellowstone supervolcano, which fell in on itself and swallowed up everything in its path, including trees, mountains, and other features. The result of this catastrophic event was the creation of depressions called calderas, with the Yellowstone caldera and supervolcano sharing the same name. Today, Yellowstone National Park is a beautiful destination for outdoor enthusiasts, but it's important to remember that this serene landscape has the potential to unleash a natural hazard like no other. Within the Yellowstone caldera, the pressure from the shallow magma body has created two resurgent domes, the Sour Creek Dome and the Mallard Lake Dome. These domes may have magma lurking as close as 3 to 8 miles and 8 to 12 miles beneath them, respectively. As the amount of magma or hydrothermal fluids changes beneath them, these domes experience uplift and subsidence. But it's not just the domes that are affected by the changing magma levels. The entire caldera floor can also rise or fall, with net inflation causing a tilt towards the south over the last century. This has led to some interesting changes around Yellowstone Lake. The southern sides have sunk, causing trees to now stand in water, while the fishing bridge at the lake's northern end has risen into a sandy beach. Despite the relative calm of Yellowstone today, it's important to remember that the remnants of the most recent eruption, which occurred 640,000 years ago, are still present in the area. In the Lava Creek Tuff region, you can see the thick volcanic debris that was left behind after the eruption. It's a stark reminder of the power that lies beneath the Earth's surface, a bubbling caldera in northwest Wyoming waiting to unleash its fury once again. Yellowstone National Park is a geologist's dream. With its vast expanse of bubbling pools and springs fueled by magma and hot fluids churning beneath the Earth's surface. The park's Norris Geyser basin alone boasts over 500 hydrothermal features, including unpredictable geysers and pools that change day to day. But this geological paradise is not just a static wonderland, it's constantly in motion. For more than 20 years, a section of land around the basin has been heaving and contracting in irregular bursts, and scientists have been trying to figure out why. According to recent research by geologists at the Cascades Volcano Observatory and the US Geological Survey, Norris has likely been a center of deformation for a very long time. By analyzing decades of satellite-based radar and GPS data, the researchers found that a magma body had intruded beneath Norris in the late 1990s. Fluids trapped inside the magma erupted out and moved through the rocky maze above, inflating the ground as pressure built up. As the fluids escaped to other locations, the ground would deflate. Today, magma-derived fluids may be found just a mile or two below the surface of the Earth. However, this new research does not suggest that the Yellowstone supervolcano, which last erupted 640,000 years ago and formed the caldera of Yellowstone, is any more likely to explode now. In recent years, the park's Steamboat geyser has also been erupting at a record-breaking rate. These geologic movements may help to explain why, and researchers have hypothesized that there may be a slightly higher risk of high hydrothermal explosions occurring in the basin as a result of the changes below Norris. While this may seem like cause for alarm, the truth is that Yellowstone National Park is a constantly evolving and changing landscape. The geological processes that shape the park are fascinating to study, and while they can be unpredictable, they are also part of what makes Yellowstone such a unique and awe-inspiring place. Yellowstone's geology is complex and mysterious, with exploring underground being an especially difficult task. However, researchers agree that the ground movements can be explained by the injection of a large amount of magma and the fluids that escaped during the eruption. Michael Poland, who heads the Yellowstone Volcano Observatory for the US Geological Survey, says that scientists are only just beginning to comprehend the dynamic nature of Norris Geyser Basin. An unexpected finding was the discovery of a massive magma plume, or pipe, beneath Yellowstone, responsible for transporting lava and intense heat through the Earth's mantle. To study seismic wave responses, researchers at the University of Utah utilized a large network of seismic sensors in and around the park. They identified a huge 3,600 cubic mile banana-shaped body, partially composed of molten rock and half a mile deeper, using 3D seismic tomographic imagery. This is the so-called magma chamber of Yellowstone, part of a skewed plume of magma that feeds the shallower magma system from the northwest and drops even deeper, 400 miles below, in plate tectonic theory. This significant discovery refutes previous claims that Yellowstone lacked a plume and is based on new seismic data. The 3D image produced another unusual finding, showing that the plume doesn't originate 1,700 miles away from Yellowstone National Park as previously thought, but instead 125 miles from an upper mantle transition zone. Despite this discovery, the Norris Geyser Basin remains an intriguing area, being the oldest and hottest thermal area in Yellowstone with temperatures of up to 459 degrees Fahrenheit. Steamboat Geyser in the basin has erupted more frequently since March 2018, with the frequency increasing from once per week to a record 48 times in 2019. Geothermal expert Helen Robinson from Glasgow University comment on the heightened activity, describing it as nuts. While the hyperactivity of Steamboat Geyser has grabbed public attention, scientists are more interested in the dramatic movements of the basin itself. The Norris Geyser Basin is an 18-mile-long region that rose by 4.7 inches between 1996 and 2004, then fell to 2.8 inches between 2005 and 2013. From late 2013 to early 2014, it abruptly started rising again at a rate of 5.9 inches per year, the highest rate ever recorded in the park. However, the magnitude 4.9 earthquake that hit the area in March 2014 put a stop to the upward movement. Since then, the basin has been gradually sinking and rising, and is now 5 inches higher than it was 20 years ago. Have you ever wondered what could be behind the chaos happening at Yellowstone National Park? Well, scientists have discovered significant changes in the park's underground volcanic system due to increased surveillance. This system revolves around a massive caldera known for its rare but massive volcanic eruptions. To keep an eye on any activity, the Yellowstone Volcanic Observatory was established in 2001 through a collaboration between the US Geological Survey, National Park Service, Universities of Utah and Wyoming, University Navstar Consortium, and state geological surveys of Wyoming, Montana, and Idaho. The observatory utilizes instruments to monitor and track any earthquake or volcanic activity in the area. Geologists speculate that the Norris Geyser Basin turmoil began sometime between 1996 and 2001, when magma rose almost 9 miles beneath the surface. Satellites equipped with radar and GPS were used to observe the deformation of the basin, which lies on a network of faults and vents called the Norris Mammoth Corridor, situated outside the youngest caldera's northwest rim. According to Geologically, the intersection of two weak zones could make it easier for magma to enter. As the magma cooled, dissolved fluids bubbled out of it, reducing the internal pressure of the magma body and causing it to deflate like a leaky balloon between 1996 and 2004. From 2005 to 2013, the ground most likely descended again due to this process. Since then, the ground has intermittently risen as the escaping fluid gets trapped periodically in pockets under layers of rock. This cycle of magnetism and hydrothermal activity has proved to be challenging to identify and document for scientists. Although the new model is a reasonable hypothesis, according to Poland, it is not certain. Additionally, according to Robinson, it is possible that sources of fluids, such as heavy snowfall, other than the magma body, concentrate in some areas and occasionally leak out elsewhere. Nevertheless, the team assumes that the magma-derived fluids are currently present in the Norris Geyser Basin just below the surface. When you step into the wild and wondrous world of Yellowstone National Park, here you will find that thousands of years of geological activity have created hydrothermal explosion craters that dot the landscape. These ancient craters are the result of intense geologic pressure that produces blistering hot water. If the rock cracks, the pressure is released in a sudden and explosive manner, creating steam in a process that is difficult to predict. Though rare, a fresh blast could occur at any time in the Norris Geyser Basin, particularly if fluids accumulate near the surface. However, according to Geologically, the likelihood of such an event is difficult to gauge due to the intricate, ever-changing nature of the rock formations. Despite this, the team does not suggest banning tourists from the area, as the risk of explosions is still quite low. As if that wasn't enough, the team is also investigating whether the recent surge in eruptions in Steamboat could be related to a buildup of magnetic fluids. Though the geyser experienced comparable activity in the 1960s and early 1980s, the team wonders why this specific geyser is so active when others aren't. Geologically admits that the connection between magma intrusion and Steamboat's hyperactivity is circumstantial, but the timing does seem to line up. The team plans to examine the chemical signatures of fluids bubbling up to the surface to determine if they originate from magma. Meanwhile, the Earth itself continues to rumble in the park as a 3.3 magnitude earthquake struck the southern region of Yellowstone National Park on August 31st of last year. So will Yellowstone's volcano erupt again in the future? It's likely, but the chances of it happening in the next few hundred years are very slim. However, if there were to be a minor eruption, it would likely result in lava flows and a typical volcanic explosion caused by a cluster of earthquakes in a specific area of the park as the magma rises to the surface. The warning signs would be more evident in the unlikely event of a much larger supereruption. The entire park would experience strong earthquake activity, and it might take weeks or months for the earthquakes to crack the rocks above the magma before an eruption. But what would happen if a supereruption 1,000 times more powerful than a typical volcanic eruption were to occur? It would expel at least 240 miles of material, lasting for weeks or months with prolonged activity. The lava flows would be contained within a 40-kilometer radius inside the park, and only about a third of the material would enter the atmosphere. The majority of the damage would be caused by volcanic ash, a combination of shattered rock and glass which would be ejected kilometers into the air and dispersed throughout the country. Now imagine a world where the northern Rockies are buried under 3 feet of ash, leaving behind a landscape of destruction that stretches across several states. The impact of a supereruption would be catastrophic, as it has the potential to harm not just buildings but also people, animals, and plants. Even a few inches of ash, which is what much of the country would receive, can wreak havoc on farms, obstruct sewer systems, and even short out transformers. The sheer magnitude of the eruption would be so great that North America would have to ground most aeroplanes, and the impact on the world's climate would be significant. The release of sulfur aerosols by volcanoes can reflect sunlight back into the atmosphere, resulting in a momentary but noticeable drop in temperatures. When Pinatubo erupted in 1991, it lowered the Earth's temperature by around 1 degree Celsius, and the Tambora eruption in 1815 caused enough cooling to harm crops worldwide. Although there are currently no indicators of an impending eruption in Yellowstone Park, the risk of an eruption is still present. However, the odds of Yellowstone exploding in any given year are lower than being struck by a civilization-destroying asteroid. Despite this, there's no guarantee that Yellowstone will explode on a predictable cycle or that another eruption will be imminent. Only time will tell if we will experience another significant eruption in Yellowstone, but for now, we can breathe a sigh of relief and enjoy the natural beauty of this incredible park. Super eruptions have happened before, and they will happen again. But what about Yellowstone, the famous supervolcano in the United States? Will it experience another eruption? The answer is uncertain. Yellowstone has been around for a very long time, and it's possible that it may not even have a fourth eruption. In fact, the heat from below and the relative cold from the surface may eventually cause the magma chamber beneath Yellowstone to freeze and turn into a solid granite body. On top of that, the volcanic hotspot beneath Yellowstone is gradually moving to the northeast, which means that the North American tectonic plate is moving away from the hotspot. If enough time passes, the hotspot will leave Yellowstone and the supervolcano there will likely no longer exist. However, this process could take millions of years or more, making it difficult for us to comprehend. In any case, it's important to keep in mind that Earth has been around for a very long time, and these systems take a very long time to operate. In conclusion, while a super eruption at Yellowstone is not impossible, there are many factors at play that make it uncertain. As humans, we can't predict the future, but we can prepare ourselves for any possible scenarios. It's essential to have emergency plans in place, to be aware of the risks and dangers of living near a volcano, and to stay informed about any potential signs of an impending eruption. By taking these precautions, we can ensure that we're ready for whatever the future may hold.